What's up, cybercreed family? Welcome back to the channel where we break down the tech that actually matters. Today, I've got something absolutely wild to share with you. You know how everyone's talking about AI agents these days? Well, Uber went ahead and built one that's literally saving them 140,000 hours every single month. And no, that's not a typo. 140,000 hours. So grab your coffee, buckle up, and let me tell you the story of Query GPT, and more importantly, how you can steal their playbook to build your own SQL agent that doesn't completely suck. Alright, let's start with the problem. Picture this. You're at Uber and you're processing 1.2 million interactive queries every month. That's like, well, that's a lot of queries, okay? And here's the kicker. Their data analysts were spending over 10 minutes per query just writing SQL. 10 minutes. I mean, I've seen people take longer to decide what to order for lunch, but still. Now, if you're like me, you're probably thinking, just hire more SQL developers. But here's the thing. Even if you're Uber with their infinite money, you can't just throw people at this problem. You need smart solutions, not more bodies. So what did they do? They started this crazy journey during their generative AI hack days back in May 2023. And here's where it gets interesting. They didn't just build some fancy chatbot and call it a day. They went through what I like to call the 3 stages of AI grief. Stage 1 was the naive optimism phase. They literally stored just 20 SQL queries with metadata and tried to map natural language to these queries. 20 queries. For a company processing over 1 million queries monthly, it's like trying to fill the ocean with a shot glass. Spoiler alert, it didn't work great. But here's what's beautiful about this. They learned from it. This initial prototype used a retrieval augmented generation technique to fetch relevant queries and reduced query composition time from 10 minutes to 3 minutes. Not bad for a hackathon project, right? Stage 2 was the RAG awakening. They built a proper RAG system that vectorized user queries, performed similarity searches against SQL samples and schemas, and guided LLMs in selecting the appropriate schema and tables. Now we're talking, but even this had problems, which brings us to Stage 3, the production reality check. This is where they built the system that's actually running today, and oh boy, is it sophisticated. Let me break down how this thing actually works, because it's genuinely brilliant. The core innovation is something they call workspaces. Think of workspaces like specialized departments in a company. Instead of having one massive system that knows everything about everything, which would be like having one person do sales, engineering, marketing, and accounting, they created focused domains. For example, let's say you want to know how many rides happened in San Francisco last week. The system doesn't need to know about Uber Eats data, driver onboarding tables, or payment processing schemas. It just needs the right data workspace. This is genius because it solves the biggest problem with SQL agents: context overload. Now, here's where the technical magic happens. They built what they call specialized agents, and each one has a specific job. First up, the intent agent. This little guy's job is to figure out what the heck you actually want. Because let's be honest, humans are terrible at being specific. When you say, show me recent sales data, do you mean last week, last month, last quarter? Do you want totals, averages, or individual transactions? The intent agent figures this out using vector embeddings and similarity matching. Here's a real example. If you ask how many drivers signed up recently, the intent agent recognizes this as a count operation with a time filter and maps it to similar patterns in their training data. Next is the table agent. This is the detective of the group. Its job is to figure out which tables you actually need. They use vector embeddings where semantically similar content has vectors that are close together in the multidimensional space. So when you ask about driver earnings, it knows to look at driver tables, payment tables, and maybe trip tables, but it won't waste time with restaurant data. Then there's the column prune agent, and this one's my favorite because it solves a problem that would make most developers cry. See, when you have tables with hundreds of columns, you can't just send everything to the language model. Token limits exist, and even GPT-4 would have a mental breakdown trying to process every single column. So the column prune agent looks at your question and says, you know what? You asked about driver earnings, so you probably need driver ID, earnings amount, and date columns, but you definitely don't need their favorite na pizza topping column. Smart, right? But here's where it gets really technical, and this is the stuff they don't tell you in those build an AI agent in 10 minutes tutorials. The vector similarity search isn't just a simple find similar text operation. They're using semantic embeddings that understand context. An embedding takes a piece of content and maps it into a multidimensional vector space, where the distance between two embeddings indicates the semantic similarity. For example, how many rides and total trip count would have very similar embeddings even though they use completely different words. That's the magic of semantic understanding. Now let's talk about the elephant in the room, the limitations. Because if you're going to build something like this, you need to know what you're signing up for. First limitation, the garbage in, garbage out problem. The quality of a model depends on the quality of its assumptions, and this is especially true for RAG systems. If your training queries are messy, inconsistent, or just plain wrong, your agent will learn those bad habits and spread them like a virus. Second limitation, the ambiguity nightmare. Natural language is wonderfully ambiguous. When someone asks for recent data, they could mean anything from the last hour to the last year. The system has to make assumptions, and sometimes those assumptions are wrong. Third limitation, the performance trap. Just because a query is syntactically correct doesn't mean it won't bring your database to its knees. The system might generate a query that joins 15 tables without proper indexes. Congratulations, you just created a distributed denial of service attack on your own database. Fourth limitation, the security headache. You're essentially giving people the ability to generate arbitrary SQL queries. That's like giving a toddler a chainsaw and hoping for the best. So, how did Uber solve these problems? For the quality issue, they built feedback loops and continuous learning systems. Users can create custom workspaces for specialized needs, which means the system can adapt and improve over time instead of being stuck with whatever training data you started with. For the ambiguity problem, they use few shot prompting with carefully selected examples. Instead of just asking the AI to generate SQL, they show it examples of similar queries and their expected outputs. It's like giving someone a template instead of asking them to start from scratch. For the performance issue, they presumably built in query optimization and monitoring, though they're not super public about the details. But knowing Uber's scale, they definitely have systems to catch runaway queries before they cause problems. For security, they use workspace based access controls. You can only generate queries for data you're supposed to have access to. It's like having different keys for different rooms in a building. Now, if you want to build something similar, and trust me, after hearing this, you probably do, here's what you need to understand. This isn't just about plugging ChatGPT into your database. The system combines multiple technologies: large language models for generation, vector databases for similarity search, embedding models for semantic understanding, and careful prompt engineering for accuracy. You'll need a vector database like Pinecone, Weaviate, or even something open source like Chroma. You'll need to create embeddings of your schemas and example queries using models like OpenAI's text embedding 3 large or alternatives. Most importantly, you need to understand that this is fundamentally a data curation problem disguised as an AI problem. The quality of your results depends entirely on the quality of your training examples and how well you organize them. Here's a practical example. Let's say you want to ask how many users signed up last month. Your system needs to know that users maps to the customers table, signed up means looking at the created at column, and last month needs to be converted to actual date ranges. The magic happens in the vector similarity search. Your question gets converted to an embedding, and the system finds the most similar example queries in your training data. If you have a good example of how many customers registered in January, with the corresponding SQL, your system can adapt that pattern to answer the new question. But here's the kicker, and this is where most people fail. You need to continuously curate and improve your training data. It's not a set it and forget it system. You need to monitor what queries are being generated, which ones are working well, and which ones are causing problems. The biggest lesson from Uber's experience is that success comes from organization and curation, not just throwing more compute at the problem. Their workspace system is brilliant because it provides focused context instead of overwhelming the model with everything. And here's something funny. They probably spent more time organizing their training data than writing the actual code. That's the dirty secret of AI systems. They're only as good as the data you feed them, and good data takes work. So there you have it, cybercreed family. Uber's Query GPT is saving them 140,000 hours monthly because they solve the hard problems: data organization, context management, and continuous improvement. They didn't just build an AI system, they built a data curation machine with AI on top. If you're thinking about building something similar, start small. Pick one specific use case, get really good training data for that case, and build from there. Don't try to boil the ocean on day one. And remember, the goal isn't to replace human expertise, it's to make that expertise more accessible and efficient. Even with Query GPT, Uber's analysts are still doing important work. They're just spending less time wrestling with SQL syntax and more time analyzing results. That's all for today's deep dive. If this got your gears turning, smash that like button, subscribe for more technical breakdowns, and let me know in the comments what AI system you want me to tear apart next. Until next time, keep building cool stuff. Peace out, cybercreed family.